Welcome. My name is Carrie Sweeney. I'm the director of the UC Berkeley Retirement Center, and I'm pleased to partner today with the University of California, San Francisco Retiree Association to offer today's lecture with Stephen Andrews. This lecture is part of a series was kicked off earlier this fall where UCSF Retiree Association and Retirement Center are coming together to join forces and offering a series of lectures for both campuses. So you will look for some more offerings coming up each month that you can register for. And while there has been many challenging things that have come up, there have been many opportunities, as there are always with challenges, and that has come from joining together with UCSF and being able to partner through offering on Zoom these events. So I'm glad all of you have joined today. I have the pleasure of introducing Stephen, but before I do, I did want to point out that we'll be taking questions throughout the session today. If you'd like to enter your questions in the chat box, I'll be moderating those and sharing those with Stephen throughout his lecture. And also, if you could mute, if you're not muted already, make sure that you are maintaining, unless we're having a conversation, that you would stay muted. And if you have difficulty finding the chat box and you just want to raise your hand and ask a question or use the raise hand feature, which is a little icon at the bottom of your screen, you could do that as well. So without further ado, today, Stephen Andrews is going to talk with us about soil, about dirt and health. And Stephen's a soil scientist and a natural resources specialist and teaches in the environmental science department at Cal. He also serves on our retirement center advisory board. And today, Stephen will present on why soil, the most complex biological material on Earth, is good for us and our health. So Stephen, go ahead, share your slides and go for it. Thank you.
Welcome, retirees from UCSF and UC Berkeley. I am thrilled that so many retirees wanted to get up for a 10 o'clock in the morning midweek talk about soil, aka dirt. That just tickles me because it is my favorite topic to talk about, to discuss. And I'm thrilled to be able to share with you today the importance of soil in our lives and how it's related to our health. And hopefully to inspire you to want to nerd up and learn some more about this, since it's the most neglected natural resource. It's one that we take for granted. We walk around on the stuff every single day, and we really don't give it another thought. You know, we have legislation for the Clean Water Act, for example. We have a Clean Air Act. Thankfully, we're breathing a little bit easier today. But you know, when you think about it, we don't have something that's specifically the Clean Soils Act. So that should give us a moment to ponder. Yes, there are things, legislation that's out there to clean up hazardous waste sites and all that, but we don't quite have the same approach to soil as we do with the resources of air and water. So part of my purpose for today's talk is to raise awareness about soil, our most neglected natural resource, and to give you an appetite for learning more about this fabulous material that's beneath our feet and that is absolutely essential to sustaining life on the planet. So let's dig in. So the first thing that I want to establish is this distinction between soil and dirt. I think it's important for us, being in the 21st century, that we think of soil in a much more reverent kind of frame, a context, versus dirt. Dirt is a cool word to say. It's got tooth to it, you know, like al dente pasta. But Soil, if you pronounce it that way, also has a certain flourish to it. And I would like us to think about and appreciate the ground beneath our feet as soil. And many people refer to me as the soil sommelier. I like that term. Sometimes I'm referred to as the dirt dude. Or the compost crusader, and you're likely to hear about all of those things as we go forward today. But soil is not dirt. Why is that an important distinction for us? Well, we frequently think of dirt as having a negative connotation, something that we don't want to be exposed to and come in contact with. And soil is something that we want to have in our lives, that we want to be exposed to, and should be more exposed to, actually. So let's talk about what dirt is. This is dirt, and note the mask on the woman with the vacuum cleaner bag that's spilled onto the carpet. Soil is not dirt. Dirt is what is in your wall-to-wall carpet. Dirt is what's in the vacuum cleaner bag. Dirt's what gets on my dog, probably your cat, the kids. That's dirt. Some people refer to it as soil particles out of place, but I think dirt is more generic than that. Thinking about what's in your vacuum cleaner bag or in your wall-to-wall carpeting is probably the best thing I can think of in terms of dirt. And that is far from what soil is all about. Soil goes through a beautiful process that we call pedogenesis, the process of soil formation. And it is one of the fundamental components of planet Earth that helps to sustain life on the planet. So I want us to be thinking about soil in those terms, a more reverent context. I want to be exposed to soil. The dirt can stay in my vacuum cleaner bag where it belongs. So we should think of soil as an ecosystem, and a dynamic ecosystem at that. So one that's constantly changing. It's responding to environmental cues, both in terms of moisture, in terms of what's in the air, in terms of plant community. It's a dynamic ecosystem. And other ecosystems are dependent upon it. You could think of us as an ecosystem that is dependent upon the soil ecosystem for our survival. As part of the introductory remarks, Carrie said that soil is the most complex biomaterial on the planet. And I firmly believe that's true, and I think there's good research that indicates how complex that it is. They ask the question, why is soil so complex? What makes it so complex? In fact, Leonardo da Vinci, back in the 1500s, was quoted as saying, "We know more about the movement of celestial bodies than about the soil underfoot." So something for you to jump into the chat with now is, why is soil so complicated? What makes it so complicated? Why do we have such difficulty understanding what soil is? So if you have a thought, quickly jump in on the chat and send that to Carrie, and we'll see what you had to say about that. Be thinking about, as you're responding to the question, think about what we know about deep space and how we know about deep space, and think about the oceans and how we know what we know about the oceans. And that might help you get a handle on why soil is such a complex material to understand. Aside from being very important in terms of Earth systems and Earth function, its complexity is something that we still haven't overcome. It makes it difficult for us. Carrie, do we have any responses from the chat about what makes soil so complex?
Yes, one just came through. The dirt is just warming up. Just a comment. Someone said many minerals, organic, many life forms. Interesting comment that the term dirt for soil is used only in American English. It shocked me when I came to the US from England. In the UK, the terms soil and earth are used interchangeably, but word dirt is not used. So they honor, it sounds like they honor, they honor this.
Yeah, so that's actually a really good point. I watch Gardener's World, which is a British program. I watch it religiously with Monty Don. And the UK is a nation of gardeners. They are a nation of people that appreciate soil as a resource. And yes, in the US, for some reason, we haven't made that connection. I'm hoping that through events like this, people becoming more environmentally aware, that we start to make a shift away from referring to the ground beneath our feet as dirt and more as soil. So let's talk about why
other fans about the love Monty Don and a couple more comments. We can move through space and the ocean easier than moving through our soil to observe, and it's hard to observe the multiple organic interactions that take place within soil. Even as an avid gardener, recognizing the complexity of soil, I have trouble seeing it. It's easier to feel the texture of rich, organically dynamic soil than to see it. So,
yes. So one of our chat responders hit the nail on the head, as I like to say. We know less about soil because it's hard to investigate. We can send a woman off into space to explore what's happening out there. We can send a woman down in a submarine to look at the depths of the ocean, but at least to my knowledge so far, we haven't come up with the technology that enables us to shrink down and to get into the pore space of the ground beneath our feet. Believe me, if that can happen, and I would love to see it happen in my lifetime, I will volunteer to be the first person to go on that mission. I fear that that won't happen, and that my ability to get close and really intimate with this material will only happen after I am composted myself and returned back to the soil. But by then, I probably won't have as much of appreciation for what's going on. Anyways, I digress a little bit. Remember, I teach at Berkeley and all that kind of good stuff. So yes, it's about being a very complex material. It's very hard to get into soil and not disturb it with our current methods of investigation, by and large. Nanotechnology, I think, will bring us closer to being able to explore the intricacies of soil. But basically, it's a complex material in terms of its chemical, physical, and biological dimensions, and we don't have the tools that enable us to really get in there and investigate it. So as we're moving forward, talking about this idea of soil, and it being an ecosystem and dynamic, I want us to also bear in mind that soil is not inert. That when I talk about soil, I am talking about something that is not only dynamic as an ecosystem, but is living. And we all need to have a much greater appreciation for soil as being alive. 25%, and that's a conservative number, of global biodiversity actually resides in soil. A quarter of biodiversity is beneath our feet. Wow, how many people have given that, some serious thought? In a square meter of living soil, we have a wide variety of organisms, from megafauna down to the most microscopic of things. And I don't have on the list viruses, because there arguably debate goes on whether they're a living thing or not, but viruses would certainly also be part of our list, since we're dealing with coronavirus and the pandemic. But if we look over my list of biodiverse things that we would find in living soil, certainly those things that we need a microscope to see dominate, and particularly bacteria. Bacteria, fungi, protozoans, microbes, they rule in terms of the soil world. And actually, they rule generally in the environment around us when we think about it. Why? Because they have had the most time to evolve on the planet. We're new kids on the block, let's face it. And so these organisms have had much longer time in the history of the planet to develop and evolve, and are much more widespread. So living soil, and thinking about soil being a major source of biodiversity, is important to us. We need to be thinking about soil, and in our gardens, whether you're an avid gardener or you do a little flower box or something that's on your deck or your patio, we need to be thinking about what those plants are growing in as being a critical source of biodiversity. And we need to be making that soil that we have, our little piece of terra firma, we need to be focusing on increasing its biodiversity and sustaining that biodiversity, because in the long run, it's critical to our health. And I'll be talking more about that as we go here today. So let's move on, and let's talk about why I emphasize soil sustaining life. Now, if we were all together in a lecture hall somewhere, I'd all have you raising your hands and wiggling your fingers, reaching up to the sun, which we can actually see today, and yelling out joyously, "Soil sustains life," the gospel according to Andrews. Yes, soil sustains life. I like this quote from Gary Jones: "Soil isn't a granular medium suffused with chemicals. It is alive, and it must be alive to function." Sadly, many of our soils in the United States are less than optimum in terms of their life-sustaining capabilities. They've been highly degraded from both industrialization, agricultural practices, development in terms of buildings and all that. So the state of our soils is not the best, and it's not only degraded here in the US, also see soil degradation worldwide. And I emphasize this because as we go deeper into the climate change regime, we are going to see more impacts associated with soil. And so how we treat soil now and moving forward and maintaining the biodiversity that's associated with soil is actually going to be key to our survival as a species. So I think it's good for us to recognize the life-sustaining importance of soil, but what makes it life-sustaining? How is it that it has come to this level of importance? And the answer to that is related to the soil food web, and that relates to the smaller critters, microscopic critters that I'll be talking about primarily today. But the soil food web is extremely complex. It's part of what makes our study of soils so challenging, that it involves organisms that are at a variety of trophic levels or energy levels within the ecosystem. And there are constant interactions that are taking place: physical interactions, chemical interactions, biological interactions, all together that make this such a fascinating material to study. When I was in my younger years deciding what I was going to do when I grew up, I couldn't decide, do I want to be a biologist? Do I want to be a chemist? Do I want to be a physicist? And then I realized, being a gardener, since I was knee-high to a grasshopper, that, hey, this ground beneath my feet has it all: chemistry, physics, biology, math. There's even cultural and societal implications that are associated with it. So I basically got my cake and was able to eat it too by going and studying soils and becoming a soil scientist. So the soil food web, which became famous with Elaine Ingham some years back, and is now widely talked about, and there's lots in the literature. It's still in its infancy in terms of us really understanding all of its complexities and intricacies, but it's something we recognize that's important and that we need to sustain. And part of our ability to sustain that is to feed soil and soil organisms. So I'll be talking about that as we go along today as well. All right, so why is soil so good for us? I've said it sustains life. Yeah, okay, that's good. We can buy into that. But you know, why should I make it more of an interest to me? Why should I have this on my radar screen and be thinking about it more than maybe I have previously in my life? Well, it's linked to our very existence. And you notice that I have replaced dirt with soil is good for us. And I mean, it's seriously good for us. Whether we're breathing in when we're gardening, compounds that are being emitted from the soil by microorganisms, whether we're playing in it, whether we're gardening in it, or whether we're even ingesting in it. You actually ingest about 2 pounds of soil or so per year. believe it or not. And that comes from a variety of things, whether it's on our food, whether it happens to be we've been outside and we got a little bit of a ring of soil around our lips and we wet our lips and in it goes. But our exposure to the microbes that are in soil is important to us. It's inevitable, really, because they're ubiquitous in the environment. So rather than focus on the downside of microbes, because we're in this pandemic, I want to focus on the positive and the benefits of soil microbes and how they are beneficial to our health. It's important to know that microbes are our constant companion. You are covered in them. We are covered in them. We have more microbes on us and in us than we have total human cells that make us up. And we have roughly 30 trillion cells that make up the average Homo sapiens sapien. And we have 40 trillion bacterial cells that are our constant companions. So that's a ratio of about 1.3 microbes for every human cell that we have. And you may have seen or heard in other places that ratio was actually much higher. But the most recent research that we have in our understanding is that while there are still more bacterial cells, microbial cells that are associated with us than human cells, the ratio is not as great as it once was thought to be. The importance here is that we need to recognize that microbes are our companions and that the majority of them are actually companions for the good. And they are helping us to develop robust immune systems, to help us with our cognitive abilities, to help us sleep at night. And I'll be discussing some more of that as we move forward. The important thing here to take away is that microbes are our companions and we should not be germophobic. We should not be running every second to get the antibacterial soaps in order for us to remain healthy. And I know that sounds a little odd given all of the recent attention to wash your hands, wash your hands. Yes, wash your hands with soap and water. That's great. But we don't want to overdo it. A certain amount of being soiled is actually beneficial to us. We can overdo our sense of cleanliness, which is really to our own biological detriment in the long run. So microbes, when we think about this in terms of health, microbes rule. Microbes rule because they have that long evolutionary history associated with the planet, and us as being a newcomer in terms of species on the planet, our early life as humans on the planet, when we were hunter-gatherers and all that, was influenced profoundly, and still is, by the microbes that were associated with soil and in the environment. Well, how do they influence us? They influence us in terms of our immune system development. So robust of an immune system we have, the more tolerant or the better we are able to deal with things like inflammation in our bodies. Microbes are actually responsible for that. And we don't often think of as microbes being associated with the amount of inflammation that we may experience. But in fact, they do have a role in terms of the immune system. They have an influence on our sense of smell. They are very important, and we're learning more and more about this all the time in terms of our digestive health and nutrition, what we're able to extract from our food, and how what's in our gut in terms of microbes actually influences the brain, our overall health in terms of mood, our cognitive function, and our ability to respond to things like stress, COVID-19, or fires, or earthquakes, or hurricanes. The better equipped we are in terms of our microbial environment, the better off we are in terms of responding to stress. And I'm going to give you some little tips on how to improve your reduction of stress by getting more up close and personal with your soil microbes. But post-traumatic stress disorder is actually known to be lower in people that do a lot of gardening, for people that are exposed to soil or have been exposed to soil microbes when they were very young. It has an influence on things like asthma rates and other respiratory ailments. And there's a lot of great work that's being done on this now. And I'll give you some sources as we go to address that. They also, believe it or not, you've heard about pheromones and how certain pheromones can make us more attractive or less attractive to other people. Well, as it turns out, microbes do that. You know, microbes, think about cheese. If I say Stilton, since I know we have somebody that's out there and knows about things in the UK, Stilton, a nice, stinky English blue cheese. You know, that smell and its flavor is related to the microbes that are in that cheese. If I say Swiss cheese, or I say cheddar, or if I say what might be underneath your armpits, those smells are influenced by the microbes that we have on us. And so attractiveness is also related to the microbes that are part of our biome. And an excellent book, Dirt is Good, by Jack Gilbert and Bob Knight, I really recommend it. This book was really written for parents to understand how the microbiome is important to the development of a child. But I also think it's great information for all of us. And it's also one more thing to get parents stressed about is my kid's microbiome, oh my God. But there is a lot of really good sound research that shows exposing kids to the organisms that are on soil at an early age has lifelong benefits. And that's part of my message today is we need to expose ourselves. We need to get off the sofa and get outside in the garden. We need to go to the UC Botanical Garden. We need to go to the Golden Gate Park. We need to go to our local parks and expose ourselves to the ground, to where plants and animals are actively roaming and living, part of that habitat, and expose ourselves to that. So Dirt is Good, a great read, fascinating read, really well cited in terms of the research. So those of you that are interested in that, this is a good nerd up opportunity. And I'll come back to that a little bit later. So it's Gilbert and Knight, and that book was actually published in 2017. All of my former students that have become MDs, or folks that are former students that are becoming parents, or family members that are first-time parents, I send them a copy of that book these days because I think it's so important for them in terms of exposing their kids to the benefits of soil. So how do we exactly get this soil, good feeling? How does that happen for us? Well, we get that, and I'm going to talk about one bacterium in particular that helps us get this feeling of wellness, of reducing stress. And a lot of research has gone into this bacterium, Mycobacterium vacca. And you'll read about it in the Gilbert and Knight book, Dirt is Good. It's also something that's talked about in I Contain Multitudes, another really good book, The Microbes Within Us, in Us, and the Grander View of Life by Ed Young. I think it's really a good book that sets the stage for us in terms of wanting to know more about the things that are cohabitating on our bodies with us. And then for those of you that are gardeners and are really interested in organic gardening, which I am an advocate of, Teaming with Microbes by Lowenfeld and Lewis is kind of the organic gardener's Bible to maintaining sustainable soils and good soil health. And it's got fascinating, wonderful images in it. And it also has great chapters on how to start composting and all that at home. So I'll be talking about that a little bit more. Let me stop there for a second. And Carrie, have we got any hot questions that people are putting into the chat that we need to address?
Yeah, Thanks. Thanks, Stephen. So we had a couple of good questions about, so I'll start with maybe some quicker questions. So what is the biodiversity of adobe soil, quote, soil versus healthy green soil?
So, okay, let's clarify. Adobe, I assume they're referring to as clay. And to back up a little bit, soil has three primary particles that make it up. We call them sand, silt, and clay. Sand, you can think of as like sandpaper. It's gritty. It's the largest of the soil particles. And all soil particles are from 2 millimeters down to 2 microns in size, or even less. And we think of sand as being the gritty particle, silt as this intermediate particle, and its feel is soft, it's sensuous, it's this voluptuous particle you just want to have all over yourself. It's great. That's silt. It feels flowery and velvety. Think of old-time talcum powder or baby powder and the feel of that. That would be like silt particles. And then there's clay, which we can associate with adobe, which is often thought of as slippery or sticky like Velcro. So we've got varying combinations of these particles that are part of the physical characteristics and somewhat chemical characteristics of soil. But it's the biology, the organic matter that really drives things. So we can have an adobe soil that has lots of organic matter in it, or a clay soil with lots of organic matter. I have one in my backyard that actually has got a lot of biodiversity and microbial diversity in it. We can also have a soil that's on a farm out in Brentwood. I live in Contra Costa County, so out in eastern Contra Costa County, that we may find does not have a lot of biological diversity because it's been constantly plowed. There have been lots of chemical and synthetic inputs, and it's been under a monoculture of some kind for a period of time. So it may be a degraded soil. So looking at them in terms of adobe or green soil, we should really think more in terms of what is the organic matter content of that soil, because it's the organic matter, the debris or the leftovers of plants that we've grown in the garden, the poop from the microorganisms and other critters that are out there. You know, Oski poops in the woods. And so that's contributing to the biological diversity of soil. Hopefully you see the distinction there. Organic matter is the thing that we want to focus on. What else have we got, Carrie?
That's incredibly helpful. Thanks, Stephen. What is meant by soil degradation? Chemical, mechanical, biological, question mark.
Yeah, excellent question. So soil degradation. I have to say that our species is primarily responsible for the soil degradation we see on the planet. You'll recall from history this thing called the Dust Bowl that happened over a decades-long period, just about back in the 20s and 30s, where we went and tore up the prairies and we blew all of this valuable topsoil off, and we were left in an agricultural deficit in terms of our soil resources. And that actually started the Soil Conservation Service, which is now the Resources Conservation Service, and a lot of ideas about how we needed to treat soil. So degradation takes many forms. Physical, that is erosion by wind and water primarily, and we are notorious for contributing to that. We are going to see erosion by water as a result of Hurricane Sally and the rains that are taking place. A lot of nutrients that come off of agricultural fields, specifically nitrates and phosphorus, they enter into the watersheds like the Mississippi River. They end up down in the Gulf of Mexico, and that increased nutrient load has actually created a dead zone. We've washed away the wealth of our soil resources, and actually they've ended up in the ocean. Because we haven't been careful with our management of soils. Fires are another example of how soils can be degraded. Particularly fires in the kind that we're experiencing now here in the West through Washington, Oregon, and California. when we have high intensity fires, high temperature fires, they can actually glass over, seal the surface of the soil, which prevents gas exchange, oxygen, carbon dioxide, other gases from exchanging within the soil and the atmosphere. And it also interferes with moisture being able to get into the soil and being able to keep our diverse microbial community alive. So fires have an impact. A lot of great research done by UC and the Cooperative Extension Service in California related to the impacts of fires on soil. And that's something we're going to need to be focusing on, since we've had now, I think we're up to 3 million plus acres that have burned this year. And we need to really be thinking about how we're going to manage our soils and soil health to get back that biological diversity. So what else have we got out there, Carrie?
Okay, well, there's two here, and in addition to, we'll share the readings, recommendations at the end, no problem, we can do that. Where are mycorrhizae in the soil web?
Okay. So mycorrhiza, I think, is what they're referring to. So mycorrhiza are part of our microbial friends in soil. I refer to them as the underground internet. So this gets back to the last question about degradation. I was specifically talking about physical degradation, but it also takes the form of chemical degradation in terms of the synthetic inputs, herbicides, pesticides, fungicides, all that stuff we put in. Those are all antagonistic to our microbial friends, but also the way we treat our drinking water. We disinfect our drinking water, and then that same water we use to irrigate our gardens, our lawns, our landscapes, and that disinfecting process actually has an impact on the soil microbial community. It kind of knocks it back. You could think of it as what happens to us when we overuse antibiotics. It can make us more vulnerable. We're not at our optimum for dealing with new invasions. And soils are of a similar kind of thing in terms of when we irrigate with water that's disinfected, that's for our public health. But we may be needing to rethink how we irrigate landscapes and not using disinfectant for our consumption, but water that hasn't been so processed, so treated in order for us to maintain that diversity. But back to the mycorrhiza. Mycorrhiza, the underground internet. Think of me as a sessile Douglas oak in California in the landscape. I have a certain biomass of roots. And by the way, more of the biomass of a plant is below ground in its roots than actually you see above ground. It's about 2/3 to 1/3, something like that. But in addition to the roots, which only go so far, I have mycorrhizal friends. Threads smaller than human hairs that actually interface in the soil, and they're fungi, so you think of them as they're part of the shroom world. These interact with plant roots, and they actually facilitate the exchange of water and nutrients to the plant roots. So they help to sustain plants. We have oaks in California because they have mycorrhizal companions that facilitate the movement of nutrients and water to them. And so mycorrhiza cannot produce their own sugars. The plant leaks through its roots carbohydrates, exudates is referred to, and those sugars are given to the mycorrhiza in exchange for providing mineral nutrients like calcium, for example, and water to the plant. And so there's this very tight relationship that has developed over evolutionary time between the microbes that are in soil as well as the plants. And we are also part of that relationship. Our constant use of the rototiller breaks up the underground internet. Just think of what this talk would be like if the internet were being interrupted every few seconds because of some, disturbance. Although it's happened when I've been using Zoom to teach classes, we wouldn't have a very good experience. And so when we're breaking down those mycorrhiza that are in the soil, we're kind of having to reset the start button again in terms of developing these connections that are so important to sustaining plant communities. This is very important associated with climate change. It's very important associated with biodiversity. Mycorrhiza are super important. We're learning more about them all the time. And in fact, mycorrhiza have now been shown to be drivers of evolution. So as the climate changes, this becomes critical because mycorrhiza can drive which plant communities flourish and which do not. And so the more diverse we can have soil, the more diversity we can have in it, the better off we're going to be. Let's take one more of the questions, Carrie.
Okay. I just got to laugh at this one, also known as the Wood Wide Web. Say that fast 3 times. How do soil microbes interact with humans? Do we breathe them and are attached to our nose hairs, ingest them when we work in the yard if the soil is in the air?
Oh, that's an excellent question. Carrie, remind me to give $5 to the person that submitted that question and for you asking it. So it's a great segue to our next part of the talk, which is you are your microbiome. Respect the microbiome. They are the 99%. And I have to thank PBS for this graphic because that's where I copied it from. We are our microbiome, and it starts from the time we're in the womb. And what we were exposed to in the womb and as we go through the birth canal and from there on is all part of how we make our way in the world and how robust our immune system is going to develop and all of that. We have this idea that cleanliness may be closer to godliness, but you'll certainly die sooner if that happens to be your particular philosophy. We are what are called termed superorganisms that have co-evolved with many soil microbes. So how do we get ourselves exposed to soil microbes? Well, yes, we breathe them in, we ingest them, we get them on the surface of our skin and we come in contact with them that way. And things that they produce can be absorbed by the skin. They can be taken in to our bloodstream through breathing. We certainly bring them in on the food that we eat. And in fact, the kind of food that we eat actually is critical to us in terms of that microbiome. Our health and our longevity depends on living in symbiosis with the soil microbiome. And by that, I mean, we don't want to abuse antibiotics because the overuse of antibiotics upsets the microbiome in our gut. It affects the microbiome that's on our skin. If we were to look at ourselves under various forms of light and staining in order to see the various microbes on us, we'd probably find somewhere around 130,000 varieties of fungal spores, that kind of stuff that are on us, among with other things. We have mites that are crawling all over us all the time, these little Demodex things that you know, we probably don't think all that much about, or it kind of creeps us out. But I know you heard talks about termites and things earlier for those of you that participated in this, so this is like old school. But one example, one way to kind of play with this idea is buy yourself a new pillow and weigh the new pillow when you buy it. And then let the pillow, you know, use it for 6 months or so and re-weigh the pillow, and you're going to find out, oh, it weighs more. Why does it weigh more? Well, you've got these dust mites that are on you that have now taken residence in your pillow. They're eating up your dead skin cells, other organisms they find on you. So we are superorganisms. That shouldn't creep us out. We should actually be embracing it and saying, hey, all right, I'm not in this alone. I have my microbial friends that are going to help. So we want to be careful about our overuse of antibiotics, not using too many antibacterial products. There is such a thing as being too clean. We want to watch how much processed food we're actually consuming, because that impacts our gut biome and our ability to digest that food and actually extract beneficial nutrients from it. And also we want to minimize our use, particularly in the garden, landscape, and in agriculture, the use of synthetic inputs, fertilizers, pesticides, and all of that, and be more organic or all natural, because that is more simpatico with the microbiome of the soil. So we can have contact with the soil microbiome and ourselves by virtue of the air, water we drink, the soil that we're playing in the garden, so a variety of ways. And we're only now starting to untease some of the different ways in which that happens. And we should actually too be thinking about promoting our microbiome to actually strengthen those organisms that cohabitate on our bodies. And what do I mean by that? Well, our gardens are actually a great place for us to be able to promote our microbiome. Because there's, we hear a lot about probiotics, and the soil microbial biology does represent a super pharmacy or superstore for passing on genes. There's actually genetic material that's passed organism to organism through soil microbes. Bacteria run along, colonies of bacteria run along the mycorrhizal fungi in soil, and they act as super networks for channeling nutrients to plants through the soil. And so when we eat organic, when we grow organic, when we eat fermented foods that are using the benefits of lactobacillus that are ubiquitous in the environment, we're helping to promote our microbiome and helping to improve our robustness in terms of ability to deal with other things that might be detrimental to us that are out there. And one of the best ways for us to promote our microbiome and in our garden is this thing, compost. Compost, compost, compost. We can't do enough of it. It helps to reverse the ill effects of soil degradation. It brings us closer to soil in terms of being able to get the benefits that the soil microbial community is providing. I mentioned that M. vacca bacteria earlier that was associated with serotonin release and gives us this beneficial feeling. Gardeners that do a lot of weeding are known to lose track of time, myself among them. And part of the reason we lose a sense of time and we get this sense of euphoria is that these microorganisms in the soil are stimulating our release of serotonin, and we get this, oh, all right, nothing to worry about, no stress, and you lose the track of time. My wife loves to weed because she gets that sense of loss of time, and she just goes on, just like has this little sense of euphoria that comes about her. And part of that is related to having a healthy soil rich in biological diversity, and has our microbial friends that are working with us and helping with our well-being. This slide has a particular calendar date that I want you to remember. And we have something called World Soil Day, and it happens on December 5th of each calendar year. And 2015 was actually the anniversary, the year of soil. And the UN Food and Agriculture Organization set up a great website, and that's what's referred to here. I encourage you to go to the Food and Agricultural website and look up the information on soils and see how soil and food are linked. You've heard of this term terroir that's associated with wine. Well, terroir is associated with not just wine, but all the food that we eat. The microbes, just like they impart flavor to cheese, impart parsnips and beets and onions and radishes and carrots. So I may grow carrots in my soil here in Contra Costa County and go back to my roots in Massachusetts, pardon the pun, and grow the same variety of carrot there. And there may be subtleties in the flavor profile that are related to maybe because of the water that's being used, but by and large, it's related to the microorganisms that are in the soil. UC Davis actually did some research on this some years back where they looked at a variety of wine grape, and they planted the same variety in 2 different types of soil, and everything else was the same. And they found that the profile of the wine, the flavor profile, differed using the same grape, but it differed because of subtleties in the microbiology, the microbes that were in the soil, and it imparted different flavor characteristics. So soil is important to us in that way as well. Carrie, we have any more questions that are brewing out there?
Sorry, I had to unmute. Someone's birthday is World Soil Day. Do you recommend no-till gardens? If so, what do we do with impacted soil?
Oh, okay, good. So I'm glad you're getting into some of these gardening questions. So compacted soil is something we largely create as a result of overworking soil. So every act of tilling soil, of moving soil, is basically contributing to not only climate change, because you're exposing carbon that's been sequestered in the soil to now be oxidized and go off as CO2, but also you're disturbing soil structure. Just like buildings, our houses, university buildings, they have a structure that gives them integrity, holds them together. And soils have a similar kind of thing. There's blocky structure, there's platy structure, there's massive, there's granular crumb, there's a number of different types of soil structure, and all those are important in terms of physical characteristics and preventing things like compaction. When we add organic matter in the form of compost to soil, it's like having a Dr. Scholl's in the bottom of our shoes, right? You put a Dr. Scholl's insert in and you have more of a spring in your step. You're a little bouncy as you're going down a hill or going up the steps. You don't quite feel the impact so much. So we can think of compost and organic matter not only as feeding soil, but it's like a shock absorber. It helps keep soil particles together in terms of forming structural units, but it also helps in terms of alleviating some of the pressures associated with over-tilling soil, over-compacting, overworking soil. So we want to be adding organic matter in the form of compost, and it doesn't have to be tilled in. It can be left on the surface. The biology will pull it down. We have friends like earthworms, roly-polies, isopods. These things pull organic matter down into the soil. And if we're using compost, we have something that is feeding the soil as well. We have another one, Carrie?
So, yes. How do I attract earthworms to my vegetable garden?
So the key to that is adding compost to your vegetable garden. And it's easy to start a home composter. Many municipalities and places like Waste Management, Republic Services, they will actually give you a bin to keep in your kitchen to collect your cucumber peels, your apple peels, your tomato seeds that you squeeze out, that kind of stuff, and to start a compost. Compost is basically an accelerated form of decomposition where we're accelerating the process by using the microbes that are in the environment to break down organic matter into its constituent elements, and then to redistribute those back out into the landscape in our garden. So if you want to get more earthworms in your garden, simply start adding compost. And, you know, if you're adding a little bit each month, it's better than adding a whole load at one time, because just like us, you have a smorgasbord and you're not going to feel so good afterwards. We want to parcel out our organic matter, our compost, little bits over time to continuously feed the soil. We don't want it to be a, wow, you fed me once for the year and then that's all I get. So constantly applying compost. And look for compost that's been organic produced. That's what we call OMRI, Organic Materials Review Institute certified, or CDFA, California Department of Food and Agriculture, Organic Input Material certified. Those would be some things to look for if you go to a garden center or a box store. Look to see that the compost that you're purchasing carries those certifications with them. You don't want things that have sewage sludge and other kind of things that may have heavy metals, and all that would be detrimental. The best is to produce your own, though, and produce it at home. Now I've got up here a slide, be happy, eat some soil, a sprinkle a day keeps illness away. And I don't mean that literally, although there are cultures in the world that do consume soil for lack of other sources of food or nutrition. They actually do that, and it's a cultural problem. I'm not suggesting that we start doing that regularly. We shouldn't be fearful of if something has a little soil on it or whatever, that it's going to be the end of the world. It actually is beneficial to us to expect. I want to wrap up today a little bit by talking about soil and another way that is beneficial to us. And this is sort of a little fun thing that I'm going to do, and then we can entertain more of the questions, and I'll talk about more of the resources. But soil not only makes us feel good, but it also look good. People go off and they spend hundreds of dollars to go sit in basically a tub of heated compost that's been cooked and all the sticks and stones kind of things removed from it, to exfoliate the skin, open up the pores, remove salts and toxins, and basically rejuvenate the skin. Well, we can certainly do that on our own if we know the places to look. So we happen to have here in California, out in the San Francisco Bay Delta, these wonderful soils called mucks. And I have one here in this beaker, and I'll hold it up with the chopstick. This is King Isle muck. It's this beautiful, black, rich, organic soil that has been made from decomposed tules and cattails in the Delta that have slowly decomposed over tens of thousands of years. And this stuff has amazing chemical properties as well as physical properties. It's a super Brita filter. You may not think about it, but soil is important to clean water. Soil is important to clean air. Complete gas exchange in a living soil takes place in the top 10 inches of soil in an 8-hour period. It's like the best HVAC system going. This stuff is fascinating. So if I'm going to take a little bit of this, and I'm going to give myself a little facial. You can see that it's nice and sticky. This is organic, so there's not a lot of sand, silt, clay specifically in it, but it's very smooth. Remember I talked about silt, and it's very smooth. I'm giving myself a nice little facial. And if you go out the Delta and you collect some King Isle muck and you put that on your skin, you'll find that as it dries, the place where you've applied it gets tight. You start to feel the skin tighten. And after you wash it off, you realize, ooh, the skin feels very smooth there, like it's been polished. And that's because of the exfoliating effect that this has. It's mildly abrasive. It's organically abrasive, as opposed to some of those cosmetic products that you might purchase that have nanoplastic particles in them. Even your toothpaste has stuff in it, these abrasives that are actually not good in terms of the environment. We should be using things that are more like this in terms of our cosmetic care. And we're exposing ourselves to the microbiome. And by the way, this stuff, I wish we had smell-o-vision, but you get the real terroir of the Delta, and I don't mean like rotten egg smell. It's very earthly. We get that geosmin molecule that you smell from the ground after a rain in the spring. It's just great stuff. So I've done this. Some of you are probably laughing hysterically that I've done this, which is good. But there is a practical side to this, that it does have beneficial qualities that go beyond us feeling good, but also it helps to sustain our skin, our largest organ on the body, the epidermis. And soil has a role in playing with that. I want to talk about a one particular resource that you can all go and get, and you can get on YouTube, won't cost you anything. And that's this movie called Dirt, the movie, a story with heart and soil. It came out a number of years ago. I've used it in my classes, both for Master Gardeners at Berkeley, at Merritt College, Diablo Valley College. I encourage all of my students to see it. I suggest you get it. It's a short film. It's only about 80 minutes long. It's very well done. Even though it was a few years back, it's still very relevant today. And it covers a lot of what I've talked about and reinforces that, but also gives you a deeper cultural perspective, the climate change perspective, the policy perspective in terms of soils, and how we should be thinking about soil resources in a global context. So I want to end up today with a little bit in terms of resources. And so I'm going to take my soiled hand here and come over and pick up some of these and tell you a little bit about them. This is an absolutely great book. It's called Talking Dirt. It's by a friend of mine, Annie Spiegelman. She's a Marin Master Gardener. She's in the film industry as well. She wrote this a number of years ago. She refers to herself as the Dirt Diva. This book is hysterically funny. So if you want to read about soil and gardening and have a really good belly laugh as you're going through it, I would recommend getting this. You can find it at Amazon used. It's dirt cheap, pardon the pun. But something, because it's written by a local author, and it has really good tips and advice in it. I recommend that you get it if you're a gardening veteran, as well as if you're just getting started. This would be a good one to get. There's a new film coming out called Kiss the Ground. This is the book that's associated with it. This is all about regenerative agriculture and about how the food we eat influences our health and our ecosystem, or the environment, by Josh Tickle. It's another one that's worth getting if you want to understand more about the underground connection that's associated with soils and the terrestrial world above ground. Kirsten Olson, The Soil Will Save Us, is a fairly recent book. I had my students read it a year or so ago, that looks at what's happening in terms of rethinking soil, both by farmers as well as scientists, industrialists, how they're rethinking soil resources and changing soil practices to be more sustainable over the long haul. Another good one is No Soil, No Life, if you want kind of a textbooky, but not too laden with things like formulas and problem sets to deal with. If you want a good general knowledge read about soils and how they are in the environment, this book, published by the Soil Science Society of America, is a really good one for you to take a look at. No Soil, No Life. David Montgomery has done a number of books about soil. This is one of his more recent ones, The Hidden Half of Nature. It's about the microbiology of soils and how that relates to our health, our wellness overall, and the ecosystem. A good one to read. Another one by him, which is even more recent, is this Growing a Revolution. And this is all about regenerative agriculture, which we're going to be hearing more and more about as impacts of climate change are felt more globally, and something to be thinking about. Something to appreciate if you want to go back and think about Darwin and the book that he wrote. Charles Darwin, he wrote a book about earthworms. And Amy Stewart, who some of you may be familiar with, she does a lot about botany, writing about poisonous plants and that kind of thing. She wrote a book about earthworms called The Earth Moved. We don't appreciate the bioturbators that are earthworms and the influence they have, as well as termites and things like roly-polies, isopods. The Dirt, the movie, is actually based on this book called Dirt, the Astatic Skin of the Earth by William Bryant Logan. He's featured in the film. This is more of a poetic romp about soils. Not sure romp is the right word, but I mean, I would roll around in soil after reading this. I would anyway. But this is a great kind of fun book to get and read after you view Dirt, the movie. One that's particularly relevant as we're talking about climate change is Grass, Soil, and Hope. It's a journey through the carbon cycle. And we have in Marin, the Carbon Project. I suggest that you take a look at that. And looks at composting and how composting in degraded fields, rangelands, actually improved the microbial community, biodiversity, and improved soil drainage structure, all that kind of stuff. And it actually, that research is done by faculty at Berkeley, so worth taking a look at. Here's another one of Montgomery's book, Dirt, The Erosion of Civilization. And then I have three here, or actually two here, written by one of my former professors, Daniel Hillel from the University of Massachusetts, now at Columbia School for the Environment, Out of the Earth, Civilization, and the Soil, History of the Soil, and Soils and Society. A lot of civilizations, societies have risen and fallen based on how they treated their soil, and that's something that we should be considering as we think about climate change and where we're going with agriculture and food supply, food security. And then finally, the other one by Hillel, this is more of a technical, textbooky kind of thing for those of you that are into equations and all of that, which, you know, some of you out there I know are. Soil and the Environment, Crucible of Terrestrial Life. So you could create for yourselves a small library and nerd up on soil resources. And then you can do one of these talks in the future, perhaps, on a specialty of yours. So with that, I am going to say thank you and open it up to more of the questions that we have in the chat and see how many of those we can address in the time that we have remaining. Carrie, what have we got?
Well, thank you, Stephen. I think you've made a few believers in soil, certainly myself. Which of those books do you think might be good for learning more about the variety of social ecosystems, or just a recommendation for how to learn more about that?
When we say social ecosystems, what do we mean?
Soil ecosystems.
Oh, soil ecosystems. Okay. I would say that the one that I would go to would be, this would be my first choice, Teeming with Microbes. So this was the winner of the Gardner Writers Association Gold Award. It's by Lowenfeld and Lewis. This one I think is just not only fascinating, but it's really well researched. And I love, love, love the color pictures that are in here. And it goes chapter by chapter about the different organisms that can be found in soil, their importance to the soil ecosystem and other ecosystems. So I would say get this one. A good one related to health, you know, Get Dirt is Good. It was written by two guys that had children that had illnesses that when they started to do the research, you know, realized, wow, you know, there's a relationship to the soil biology and my child's illnesses. And so this does a really good job. And I mean, this is not hocus pocus science, fake science. It's not hyperbole. It's well researched. And that's one of the things in this area is that there are folks that sometimes do research and then it gets a little bit of a hyperbole attached to it. And then a media catches it and it's like, wow, soil microbe, greatest mind-altering drug or something. You know, that's hyperbole. We want to look at the stuff that's science-based. We should all recognize how important science is. And remember, it's a social institution. So we need to be thinking about, those are two good ones.
Great, I think that's a good start, yeah. We got a few other questions here, and
okay,
I think you're among friends with science for sure, science believers. So this is a big question. So I mean, maybe you could answer it, you know, kind of broadly. What is the impact of climate change on soil?
Yeah, I stopped off the sharing here so you can see me.
Yeah,
The impact of climate change on soil. Well, there isn't a simple answer to that,
that's
right?
what
It's
I
the most
figured.
complex
Yeah.
biomaterial. But I am going to give you an example of what we've learned and how soil responds to changes in climate. So some research that was done a few years back in the rainforests in Central America, they wanted to know how quickly the microbial community would respond to changes in rainfall. So for example, if they started to experience drought in the rainforest, would the soils respond, and would that response be beneficial to the plant communities? And they found out, let's do an experiment. So they blocked plots within the rainforest that would not get regular rainfall. They were put into a drought condition. And they analyzed those areas that got the drought condition versus the one that got the normal rainfall. And they found something amazing. The soils quickly changed in terms of their microbial community. They went from having more bacteria doing things to these things called actinomyces, which are a kind of a hybrid between bacteria and fungi, and their populations increased. Why is that important? Because the microbial community, remember I was talking about fungi, mycorrhiza, being drivers of evolution. As we get into more of a drought kind of environment, temperatures rising, soil microbial community changing in response to that could really help us in terms of our global agriculture. So we may want to be thinking about plants, agricultural crops that actually will respond well to changes in the microbial community as temperatures rise, or thinking about things that we haven't been growing that will work more effectively with the soil biology and can be beneficial to us. So in general terms, fires have an impact on soil, erosion has an impact on soil. I'm gonna sneeze. I think I got a little King Isle muck in the nose. These are definitely having an impact, and we are going to see more of it over time. The problem is it's not like a light switch thing. You flick it on, you flick it off. These are going to be gradually increasing incrementally, and they're not going to be dispersed evenly. We talk about climate change and things getting warmer, but doesn't mean that there's also going to be the flip side. Some places may experience increased cold for some period of time as a result of some of the changes that are happening in climate. Certainly the sea level changes as we lose more of the polar ice caps. That's going to have an impact on weather patterns, ocean circulation patterns. And I'm not an expert in any of that. So, I want to be cautious there, but you could certainly nerd up a lot by investigating more on that.
One of the books that you recommended was related to climate change, and
Yeah,
right?
actually, a number of these do talk about climate change.
Okay, great. You got a bunch more questions, and we can
Fire away.
take what you feel like you can answer more thorough, with more expertise, or not. Do hydroponically grown foods lack the probiotic benefit?
Yeah, so I have to, for disclosure, say I am not a fan of hydroponically grown foods, right? I mean, they're grown in a nutrient solution. So we don't really have the benefit of all those microbes and things interacting. So yes, we can put nutrients in the water. We can grow a tomato. We can grow lettuce. We can put them under fancy, sexy lights in a warehouse somewhere. But is that what we want the planet to go to feed the human population? I say, God, I hope not. I want soil because that's what the planet, the organisms have evolved with, we've evolved with. We should be thinking about how we make that work and do it sustainably versus too much emphasis on technology. But again, for transparency, I have a bias. I'm a soils guy. So I'm not necessarily a fan of hydroponics. There are closed systems that use some hydroponic, some soil, aquatic habitat. There's some components to that are simpatico, make sense. but I believe in this idea of the whole ecosystem and soils, the lithosphere, the pedosphere, being intimately integrated with the atmosphere and the hydrosphere and us, the anthroposphere, and hydroponics is in a good way to keep those all connected really well.
There were a couple questions I think you covered briefly on how on wildfires and the influence of drought. So I'm going to, you gave good examples of the glazing over, and as well as the one when you were talking about the holding the rain off. So I will move down to how deep is soil, and then how do gophers affect soil and soil structure?
Ah, okay, well, good question. How deep is soil? Well, where are you? It depends. Soil can be fraction of an inch in terms of its depth, down to the mucks and things that I study out in the Delta where they're, 6, 7, 8, 12 feet deep. It really depends. There's that process of pedogenesis, the factors of soil formation. They involve climate, the biology, the topography, the parent material. Did the material that started the soil come from a volcano, a flood, a glacier? All of these things have influence on what kind of soil forms. The important thing to remember is that there is no such thing as a bad soil. There are only good soils that have had bad things done to them. Every soil has a place in the landscape on the planet. Our job is to understand that and to protect, to preserve the functioning of that soil. And not so much think about, okay, how are we going to maximize what we can get out of it in terms of a corn yield? And we want to be thinking about that biodiversity, the health, because that has a global context to it, and we should be thinking about it that way. And then about gophers and
Gophers.
other critters, I've had gophers in my yard, and I say, live and let live. They are bioturbators. They are, that's their habitat. It's their home. I don't want to create homelessness, even if it's for gophers. Now, I do combat the gophers. My dog has to go poo and he has to wee every day. So I collect his poo, I collect his wee, and I put it down a gopher hole. They don't like that very much. I grow things that gophers don't like to nibble on. And I strategically place those in my landscape so it discourages them from taking up permanent residence. But I would, not go out and start like fumigating my yard and all that kind of stuff to get rid of a few gophers. Rethink your landscape and try to live, cohabitate with the other partners that you have out there in the soil world. That includes snakes, spiders. Basically, you pick anything out of the plant kingdom, and it's going to have some association with soil. Okay, we got another one.
Well, this is good because it ties, I think, into if we're to learn more about soil, and say we're coming at this new, I'll speak for myself, I'm very fresh to this, tying it maybe to compost. And there's a question about, are there any food scraps that we should not put in our compost? But thinking about how do we put our foot in this and get dirty and start to really explore these elements that you're talking about as a way to learn more.
Oh, Carrie, that sounds like a great opportunity for another talk in the learning series.
Okay,
we
great.
should have one all about composting.
Wonderful.
That would be fun. I can give you some resources, some links to some videos, and you can post those on your website, and people can link to them. And also some training. You should check with your municipal waste company like Waste Management or Republic. They probably have a compost training program in your area, so you might want to check with them about it. Their quality varies, but it all starts, you don't have to be a homeowner and have a yard to be a composter. You can have an apartment and be composting and feeding your houseplants or what you've got on your patio with compost. So I think I'll provide some resources, but I think we should have that as another talk.
We'll have
Originally,
another talk.
when we were planning this, I was intending to go out and do some of that in the garden and show you some of the critters, but the air quality was such that I had to change the strategy on that. It's better today, but it's still not, you know, completely
That's
great.
right.
But I think that's food for another program.
Absolutely. I think you've made some fans today, so I'm sure we'd have some followers. Do
Yay!
you recommend putting plant waste at the bottom of a trench that you are going to plant?
Yes. Okay. So I didn't completely answer that last question. So things you should and shouldn't put into a compost pile.
Oh, yes.
Unless you're, and it relates to the one you just asked. If you're a newbie to composting, you want to keep it simple, you know, the KISS principle, keep it simple, sensible, okay? And that means just the kitchen scraps, plant material kitchen scraps that are fresh. Lettuce leaves, carrot peels, rotten tomato, watermelon rind, that kind of stuff you can put into a container and compost. The microbes that are ubiquitous out there, they will start to feed on that, decompose it. It's going to get hot. It's going to cause it to break down. And the nutrients will be released as a result of that decomposition process. And you can feed that back to your plants. You don't want to be putting in things like meat, cheese, dairy, fats. Those kind of things are not what I would say a new novice composter should be doing. The commercial composters, the ones that pick up your green can where you may be putting your food waste, they do handle that, but that's because they're dealing with tons and tons and tons of it in an industrial process. I have to say though, it doesn't make the best compost. What you make at home is far better. So make your own. Homegrown is best. So you can do what's called a trench method to get to the last question. And you can dig a trench in your backyard. And I would make that about 18 to 24 inches deep. And you can put your waste into that, cover that over with soil, let it go for 6 months to a year, and then plant your tomatoes in it after that. And it will do the process without much effort from you. I say 18 to 24 inches because you want to keep our raccoon and opossum, you know, maybe kitty cats, other things from wanting to dig into your scrap pile and find things to eat. So that wouldn't be my first choice. I would recommend a hot composting you do outside in a bin, and that can be for our next talk, or what's called vermicomposting, where you use manure worms. They're fabulous things, and you can do that in your house. I have under my kitchen sink a bin with worms, and I throw my stuff underneath after I do the carrots, and the worms go wild. My wife was very against this. She thought, it's gonna stink, it's gonna have flies, it's gonna be awful. She is now she thinks of them as pets. Like our dog Huxley, she loves to watch the worms. When I separate the castings, she watches them wiggle around. She loves watching them reproduce too, I have to say. She's quite the worm voyeur. And they're hermaphroditic. They will exchange sperm, fertilize each other's eggs. So they love to do three things: eat, poop, and have sex. So worms in your kitchen are actually not a bad thing. They're not like roaches, people.
Well, talk about keeping it simple. So the next question then is, in California, many native plants and thus wildlife that lives with them evolved with what I believe you would describe as poor soil. So to what extent is what we consider good soil cultural? And that sounds like a time, maybe another talk too, but I think you've touched on that a little bit around how cultures have, there's been demise of culture based on how they've cared for their soil.
Yeah, so I mean, poor soil is like, poor soil is like saying something is a weed, right? Weeds are plants. We just call them a weed because they're growing someplace we don't want them. So we call a soil poor because we're trying to grow something in it that probably doesn't belong there. So my great example is you go to Kew Garden, you go across the pond to Kew Garden and you see Stevus andreosi, and you want to bring one home from Kew Garden and plant it in your backyard. But it grows in a soil that needs a pH of 5, an acidic soil, and it grows in a boggy environment, and you try to bring it back and grow it in the driest part of California, and you're very disappointed. You say, I have poor soil. My Stevus andrerosi won't grow. Well, it's because it's not a good soil plant fit. So like I said earlier, there is no such thing as a bad soil. There are good soils that have had bad things done to them. So we need to make sure that what we're growing is simpatico, fit to grow with the soil type that we have. And yes, we could make that a whole cool conversation too.
Yeah, there's a couple more questions about compost, but a related one to the one you just answered is that some native plants are said to prefer poor soil. How should a gardener interpret that when adding compost to areas intended for native planting?
Okay, yeah. So yeah, I would caution the use of poor soil. And
they put that in quotes.
Yeah, yeah.
Just to be fair.
So I mean, that's something that we say it's poor. For our California native poppies, it's like just right, because they've evolved to grow in that kind of environment. So by that, we're meaning that they don't necessarily need a lot of organic matter enrichment. This is kind of a hotly debated topic, actually. People in the California Native Plant Society, you know, go, no, we shouldn't amend with compost and all that. And then also when you think about climate change and some of that, you go, well, maybe a certain amount of organic matter because of soil degradation, you know, that's actually, it could be an important thing. So I would say, again, it goes to, if you've got California native plants, know what those native plants grow in, and then you should be moving accordingly. Sometimes it's better to put things in a pot. I honestly think California native plants are going to be tremendously vulnerable because of climate change. You know, we're talking about this 6th major extinction, whole nother topic. But a lot of our native plants may go the way of the dodo bird as a result of climate change. So we need to be thinking about resilience and soils being resilient to maintain certain plant populations. That's something I would be thinking about. So
it's 11:30, and there's several more questions, but I'm sure Stephen would be very willing to answer if you email him, and happy to get back to you on that, and we could add another other lecture. There was a comment about the use of word dirt in the books. It's going to take it seems to be grabbing attention, but we're going to bring sexy back, as they say. We're going to bring soil back, right? Yeah, soil with an accent. Thank you so much, Stephen. To everyone, this recording will be available, and a list of your readings. Perhaps we could get a list of those books from you, Stephen. If you want to send us pictures of them, we could probably compile them into a written list for you. No problem, if you don't have that already. But I want to thank you for your time today, and thank everybody for staying on. Everybody stayed on, and hopefully you'll be seeing soil in a whole new light. I certainly am. So thank you, Stephen. Yay. Everyone, have a great day.
Soil sustains life.
Yeah.